let us start with this combination on a ballistic rocket. इसको बंद कर देना बेटा. In this problem, he is talking about a rocket which is launched from the. This rocket is launched from the pole of the Earth with the first cosmic velocity. That is the near Earth orbital velocity. We'll use it in such a way that it lands at the equator, right? Radius of Earth that is given to us. So there are these three questions which he has put up. We need to find out the longer semi-axis of the rocket's orbit, first part. Secondly, we want to find out the maximum height of the rocket's orbit from the surface of Earth. And third, he is talking about the rocket's flight time. Right? So let me draw the fundamental picture. Let's say this represents Earth. This is the pole point. This is the equatorial point. यहाँ से launch किया है और finally it lands up here. So let me draw a orbit, an elliptical orbit, which is somehow symmetrical and something of this sort. I mean, if I would have completed it, it would have looked upon like this. So, right. So this is the line of symmetry for the elliptical orbit. ये आ गया. Now, the focus of this ellipse should coincide with the center of Earth. But because of the mass distribution, the mass of this rocket I am presuming to be very, very small in comparison to the mass of Earth. So this point will be nearly touching the end. So the focus there or the end point, that will be convergent at nearly one point, and that will help me state that the point connecting the projection point and the ending point, these 2 points, the center of this ellipse will lie on this point. I'll call this point as O. Right? Now, this is the orbit we are discussing here, and distances you can find out. Theta, I think, is also clear to all of you. That comes out as 45. So what are the values we are getting? Calculation. We are getting distances. These distances are coming out as r by root 2. This is also coming out as r by root 2. This is apparently also coming out as r by root 2, right? So that AE distance is indirectly coming out as r by root 2, r by root 2. So let us keep this equation as such. And to begin with, his interest was to find out the value of A. So what is the first equation we are willing to write here? As far as the total energy of this satellite is concerned, net energy in his orbit, that should be equal to minus G capital M small m upon twice of A. Right? That term should be equal to, what are the terms we can write for this net energy? So when I have projected it from that place, so there I have got a term which is, actually it is minus G capital M small m by twice of R. And that's why I'm saying that A should be equal to R. Just check why I'm writing this, because this term is actually comprised of minus G capital M small m by radius term, and then a half m V square term, the initial square term. And he has already said that you have thrown it with the first cosmic velocity. So by orbital term, this term is actually G capital M by capital R. So this becomes equal. And that tells me that A should be equal to R. And A being equal to R directly tells me that the eccentricity of this elliptical orbit comes out as 1 by root 2. Now, secondly, when he says, what is the maximum height? Let us look upon the second part of the problem. So we are discussing this distance h here. क्या लिख लेना चाहिए? What should be the value of that distance? It is coming out as A minus R plus AE term. Yeah? Huh? R minus A term, which is kind of the same, plus AE term. And so that is actually R minus A term and plus a AE term. So that is nearly coming out because E is approximately R. So these terms are cancelling out. And this AE is giving me a value of R by root 2. So my H is apparently coming out as R by root 2. That is also fine. And when it comes to the third part of the problem, so I need to find out the area which it has subtended. So think like, if you can find out the total area that it has subtended, we are talking about the area, the half area of this ellipse and the area of this triangle. So what we are trying to do for third part of the problem, I want to find out the ratio of this green area with the total area of this ellipse, and then I will multiply with the time period for the complete elliptical part. Yeah, क्योंकि उसी ratio में आ जाएगा. So the area which is subtended at the focus, then the total area of the ellipse, and then I will multiply with the time period, the time that it takes for the total subtended area. So just some calculations we have to be careful about. So total area, that will be pi AB term, right? So that should be pi, A term is R, B is coming out as R by root 2, right? What about this term is root 2 here, R by root 2. So what about the subtended area? And then I will write the time period and finish off the combination. So AS का value लिख देते हैं. So let us try to write this term carefully, AS term. That is half of this area. So it is pi R by root 2, pi AB term, right? Divided by 2 plus the area of the triangle. So that area comes out as R90, R square by 2. That area comes out as R square by 2. So when I say area subtended, that is coming out as pi AB by 2 plus R square by 2. And this value is also pi R square by root 2. Now if I can write the time period correctly, I'm done with the problem. So the final step here is to write this term for the time period. So let us write this. For the complete elliptical orbit, the expression for the time period. वो जो circular orbit से आता है वही आ जाता है, and radius gets replaced by the semi-major axis. So 2 pi root of R cube by GM term. So that in this problem is kind of 2 pi root of, because A is coming out as R cube upon GM, and I think that will come out as G naught into R square. So that seems simple. It should be 2 pi root of R by G naught. 2 pi root of R by G naught, that directly can be used here for the elliptical orbit also. It is root of A cube upon GM term there, but that it has been proved that in this problem that A term is nearly equal to R. So some direct results I have used, then it is a simple problem, right? Okay. Let me take up the second problem, which involves energy Bernoulli's equation and some results from thermal physics also. So just read this problem based on a water pump. I'll explain this question, kya keh rahe hai, and then we will go step by step. To read that question number 4, which is based on a water pump, I'll explain. Consider the following construction of a water pump, which consists of, so I will tell you the critical things. So there is a vertical tube here. The area of cross section of this vertical tube is S1. So there is a wide drum, open drum, which is containing some liquid. In that wide drum, I have inserted a cylindrical tube, which is going up to height of h. That cylindrical tube has got an area of cross section of S1. When it reaches the top, there is a cylinder, which is closed from top. Closed, the lid is closed. And that cylinder here, this cylinder here, has got some small holes, lot of holes, symmetrically distributed on the curved surface area of that cylinder. Right. Now the question goes like this. This area of cross section is S1, and there is an open leads from an open reservoir to a cylindrical rotating. There is a motor which is ensuring that this cylindrical top is rotating with some angular velocity omega. You can see the top view, and you can see the holes which are there. And this guy has got a radius of r. All the vessels are filled with water, and there are holes of net cross section. So need to understand that these small holes, इनका जो total cross sectional area है, that is S2. Net cross sectional area is S2 along the perimeter. Now, which are open for the operating regime of the pump. The height of the tank from the free surface of the reservoir is h. So this height is given as h. एक electric engine है. There is an electric engine which keeps the vessel rotating at an angular velocity omega. That engine or the pump, whichever way, the water density is rho and the air pressure is P naught, right? And the saturated vapor pressure, that is Pk. The saturated vapor pressure is Pk. Assume that the water flow is laminar, no loss of energy is there, neglect friction, and there are metal blades which make the water turn. All the assumptions are. So within the bulk also there are blades. Now the questions are there, and he is building up the problem actually. So the A part of the problem says, calculate the pressure P2 at the perimeter of the tank when all the holes are closed. So try to write the function of P2 at the perimeter of the tank when all the holes are closed. Let's see what that function will be in first part. जो ऊपर वाला डिस्क है उसका जो कर्व्ड सरफेस एरिया है, at the curved surface area he wants you to write the pressure. So all the holes are closed. So by virtue of omega also, that centrifugal thrust is developed, but motion is not there. So it seems like if on the surface I can write pressure term V naught. Okay. So like even if it is rotating, this guy is rotating with omega, the pressure that I want to write is P2 is P naught minus rho gh term. So now I have reached the center of the upper disk, and now from the center, because of omega, there is centrifugal thrust which will change the pressure parabolically as you will move radially outwards. and that term will come out as rho omega r square by 2, rho omega square r square by 2. Check this. Here, because even if I take a cylinder and just rotate it, that pressure can be written easily. Or directly also you can write by center of mass. Yeah, that's fine. So A part was simple, right? B part, he says, from now on, all the holes are open. Find the velocity of the water jets with respect to the ground in the second part. थोड़ा ध्यान से लिखना, because the pressure that you have got there, and outside pressure is P naught. So that term half rho v square will give you some velocity. I mean, the answer to this question should be root of, because they will have two velocities, na? ऊपर वाला omega से घूम रहा है. So all the liquid which is coming out will have a tangential velocity, which is r omega. So r omega whole square plus the relative velocity square term. And if you write this pressure and P naught and write it as half rho v square, so that seems to be what? 2 by rho times this term, which is minus rho g h plus rho omega square r square by 2. Check this carefully. So the velocity which he wants me to write, V2 should be root of this quantity. And check this. So r square omega square term, and again r square. So it seems like 2 r square omega square minus 2 gh. That should be the answer for B part. है ना? So pressure लिखते वक्त rotating frame is fine, but when you are writing that velocity, you have to be careful. Now comes the more interesting part, C part. D is in fact the best one. अब C में कहता है, if the tank rotates too fast, the pump efficiency drops, and that is because of cavitation. So he's talking about something called upon as cavitation. तो अगर omega आपने बहुत ज़्यादा कर दिया, then it will cavitate. So what he wants you to do now, what is the highest cavitation-free angular speed? What is omega max? And that should be cavitation-free. Try to just write the expression of C part. Lot of things we have to be careful about in this part. So gradually I'll build up C part. Let me write the equations carefully. I will be applying Bernoulli's and equation of continuity. So let me first try to write continuity equation. क्या लग रहा है? The velocity with which, now if let's say I'm rotating it with some omega, so liquid is consistently being transferred from the lower side to the upper surface with some velocity at that omega. So I'm calling that velocity as V1 here. In this complete pipe, even at the center where it will come, from where it will splurge, that is V1. So S1 into V1 term. Let me now look into the other terms. That should be equated with, because the velocity जिससे वो निकल रहा है ना, इसमें that r omega doesn't do anything in volume flux. So that should be equated with the total S2 of the holes multiplied by the relative velocity with which it is coming up. And that relative velocity we would have calculated. So I think it should have been this term only. Yeah. So it should be root of minus 2gh, and plus what term? Omega square r square. Good enough. Plus omega square r square. It works. This seems to be the first equation. Check. Seems like S1 V1 is equal to S2 into root of omega square r square minus 2gh. That is good enough. first. Secondly, from the top surface, now I want to write one equation from Bernoulli's, that is from the top surface to the center point where liquid is just coming up with V1, and this is all pipe where the velocity is V1. इसके बीच में लगाते हैं. So at this point, only pressure energy is there, that is P naught. इसी को reference. So when I write those terms at the midpoint, I'm writing pressure there as PM. That is not exposed. It's a closed vessel, and I'm at the center point there. Height is very, very small. Upper vessel का height बहुत छोटा है. I'm talking about this thickness. This is tending to zero, the thickness. So P आ गया, plus I will have a rho GH term, plus I'll have a half rho V1 square term. Half rho V1 square term. This much is fine. इन दोनों इक्वेशन को सॉल्व करो. Substitute your V1 here and try to find out PM. The matter of fact is, why I'm interested in that PM, in this configuration, the least pressure, when he says find out the highest cavitation free angular speed, so the statement is that the least pressure is actually at the PM pressure. I mean, ऊपर वाला जो structure है, at the center, on the axis of that structure, the pressure is the least. Already P naught is decreasing up to that point, and afterwards it is increasing. So that is the least pressure point. So basically what you need to do, from these two equations, solve for PM, that is P least, and ensure that this becomes equal to P saturation vapor pressure. So if this becomes Pk, exactly at that moment, it will start boiling. The cavitation process will start. So your omega should at least be this much, but should not be higher than a subtle value. You're getting my point? That limiting omega or the omega max is the value where the pressure on the axis of the upper constriction becomes Pk. Right? क्योंकि वही लीस्ट है और सबसे पहले वहीं से सैचुरेशन वेपर प्रेशर वहां आने से cavitation will start from that point. So if I can avoid cavitation there, it will not be present anywhere else. So you just write and solve this equation. I'll tell you, when I substitute PM to Pk and solve these two equations, one result that I will have is omega max, and that comes out as 1 by R, after solving all the equations, root of 2GH plus P naught minus Pk upon rho minus GH whole multiplied by S1 by S2 the whole square. That is the value you will get, omega max. And now we will go to the D part of the question. So calculation is fine, you can take care of that. Read the fourth part, the last part of the problem. Now he says, and this is again interesting, he says if the power of that electric engine is P, the power of the electric engine, if that power is P, can you tell me the theoretical upper limit of the volume productivity of the pump? Volume pumped per unit time का maximum value mu max can be predicted? That is the question. There are two subtle thoughts which you have to be very clear about if you want to write this correctly. Power of the electric engine is P, right? Now, the thing is, whatever I am supplying per unit time, that is utilized for two things. At a consistent rate, I am pulling up some liquid from this height to that height. So I'm changing the potential energy at a constant rate. And there is some energy which I am throwing out of the system. I mean, those uh, people who are being thrown away from these holes, they are taking away some kinetic energy per unit time. So basically, what are those two utilized forms of energy that you want to write? Just see, क्या है आपका term? And one more thing, I have to also ensure the cavitation wala issue that is also there. The thing is, if you look into your expression of omega max, there is again a limit to that expression. Let's see what is the expression. Now, before you can solve for D part, you need to see your expression here. And you need to see that the limit that you can provide for this value is 1 upon R into root 2 GH. That term can have a value of 0 also. So root 2 GH by R, from cavitation free process, I knew that this is the max I can have. But this value also depends upon different configurations. I am trying to find out the highest efficiency for the system. The question is clear, bole, that if the power of the engine is P, the theoretical upper limit, so that limiting value of omega that I can see is this. Out of these values also, I know I can, if I take a limiting value which is this, obviously the maximum utilization I can that can happen for a power P will happen only for this omega. Think about it. And because if this can be provided, that means while it will come out, it will have a R omega term which will become root 2gh. That velocity will be there, root 2gh. And along with this, it will have a radial velocity term also. Write those terms. Kya hai wo second term? What is that you are getting? Under any situation, you have to understand that this language will have a subtle implication. What I am trying to do right now is, what is the least energy that I have to spend that I am trying to find out? Two things are happening categorically. One thing is I'm lifting liquid by a height of h. So few energies which are definitely to be utilized under optimal situation. दो बातें दिमाग में आ रही है मेरे. एक है, if I write mass per unit time as mu, I'm writing mu as my m dot. So I think mu gh, that is one consumption. You are lifting it by a height of h. And for this thing, there is a r omega velocity which it will definitely have, even if you don't provide it any thrust. So basically, half of mass per unit time into that velocity square. So that becomes actually mu into gh term, UGH. Right? So no kinetic energy being spent in the form of excess thrust of throwing the liquid. But because of omega, I will have at least this much. And that omega also I have taken up as the least possible value. So my least possible potential energy, the kinetic per unit time, this is K dot, this is U dot, so E dot, least possible, I'm solving for least possible, that becomes 2 mu GH. And if that is made equal to the power of the engine available, that means the mu in terms of this mass per unit time is P upon 2gh. That should be the answer. And it is mass per unit time. You can take divided by rho. P by 2gh should be the limiting value, because he said categorically, what is the theoretical upper limit of the volume productivity? So you just compensate it by rho. I am talking about the mass productivity. Again, I will explain what I am trying to say here. I am saying that if you want to utilize your engine, which has a power of P, you have to supply, like mass per unit time GH term, you have to pump liquid up. The liquid that comes up will be given some omega, by virtue of which it will have some velocity of r omega while exiting from the holes, and some thrust VREL also. So now I am trying to decrement my kinetic energy to the minimum. और ओमेगा की वैल्यू मुझे पता थी. Out of all these maximas possible, I have chosen the least. So that least value I got upon as root 2 GH upon R. The reason was obvious. As an engineer, I never wanted to maximize my productivity in terms of energy per unit time. I never wanted to waste or supply any excess kinetic energy. मतलब पंप मेरा चल जाए, this system just starts working. For that, I am trying to write the expression. So I just wanted to push liquid out without cavitation also, with no rel velocity, just fall off from it. But because of my omega, you will get some r omega also. So no cavitation is happening. One thing that I have ensured. And I am throwing the liquid out, but no excess V have been given. VREL has been given. So that omega I picked up from here, and then I used VREL to be equal to 0. That gave me some kinetic energy form, which will be there. Minimum hai. And this is again the minimum potential energy per unit time. Then everything was fine. So under the limiting condition, this was the most optimal utilization of the power of the engine. So when he said in the question, if you look into the language, you will relate it better. This is the maximum productivity. इससे ज़्यादा mass per unit time आप lift up नहीं कर सकते with the engine power, which is P. Is that clear to all of you? So that was the D part of the problem. Let us pick up the third question for the day. Now this problem is from 200 puzzling, very conceptual kind of idea. I'll take some approximations, we'll solve it out, and then I will explain why I have taken that. Question was straightforward. He said that if there is a superconducting uniform spring, okay, you should treat it like a solenoid. So superconducting uniform spring has n turns of radius r, radius capital R. Relaxed length of the spring, solenoid को spring की तरह देखो, relaxed length is x naught, and the spring constant is k. The two ends of the spring are connected by a wire, so it becomes a loop. The end point is connected by a wire, so it's a complete loop now. And a small steady current, capital I, is made to flow through the spring. अब जब उसमें हमने current चलाया, this capital I, the question was, at equilibrium, what is the change in its length? What is the change in the length? Forget gravity in this problem. The only thing is in gravity-free space, this is an ideal spring, ideal solenoid kind of configuration. सब कुछ दिया हुआ है. The starting point and the ending point is connected with a wire, by a straight wire internally. So it is a complete loop. If you drive a current of capital I through it, what will be the change in the length in equilibrium? That is the question. Right? So let us try to write the expression. Now, one thing that we can say by Faraday's law is as the loop is superconducting, there is no resistance in the loop. So the total flux will remain constant. Not only this, if I just think like this, that this is a general state, and you have connected these ends with the help of a wire, and you have driven a current I into the loop. So in a general state, if this length becomes x. Number of turns are n, the total number of turns, and radius is capital R, so this is 2 capital R. All the changes that we want to study are small. So I will neglect the change in the radius. Right. Now, in this general state, I want to write the total energy of this system. I want to see what is the total energy of the system. So seems like I should write B square by 2 mu naught into the volume, that is the magnetic energy. And I should write the spring energy also. So with, considering small changes, it looks like half k x minus x naught the whole square. So k I have not changed because of change in length. Changes are small. You understand what I'm trying to do? I'm trying to write this total energy, which is actually a potential form, as x. And then I want to find out the equilibrium position with the help of potential energy. That is the idea. So, अब B कैसे लिखें? So B should be mu naught Ni. So N by L. L is x, number of turns per. So current is I, this whole square, upon 2 mu naught. And that volume term there seems like pi r square into x, right? Plus. And this expression is half, so that's fine. I mean, half k x minus x naught, the whole square. Now, this is my first equation. I want to write the expression of dux by dx. I want to see this general expression. dux by dx. Differentiate karna. What is that you are getting? So mu naught n square I square pi r square by 2, and you are getting a 1 upon x term. एक बार calculation देख लेना. All the terms are fine. So 1 upon x term was there. So comes out as minus 1 upon x cube term is there. Minus 1 upon x square, fine. So that term was 1 upon x, baki to constant is fine. Okay, fine. And I'll have half of k, and this term becomes twice of x minus x naught. This term will cancel out. So if I want to see the equilibrium position, and for that, if x minus du by dx, that term I want to make equal to 0. So indirectly, we are trying to say that this expression should also be made equal to 0. I'll come to the theoretical point which I indirectly use. So I'll use two methods to solve this problem. Let me first write this expression, then I'll go back and explain the main fact. There is a catch in the expression. Now, just try to write the expression from here and assume that x is nearly equal to x naught. Let's see what expression are we getting in this problem. Check that. Are we getting x naught minus I square mu naught pi r square n square divided by 2k x naught square? Are we getting this expression? वो तो x is equal to x naught के about ही लिख रहा हूँ, and this is the value of x, and I was using this approximation मैंने use कर लिया कि x is nearly equal to x naught. Under that approximation, this expression is what you achieve, which is actually the given answer in this problem also. Now, this was a fundamental way of solving. The more appropriate way that I'll discuss, which will give you the correct answer again, was constancy of flux. I mean, everything is fine. The reason we got the correct answer here is because that term will be compensated. Like what I'm trying to say is, somebody can say, fine, let us try to write the flux. Flux should remain constant. By Faraday's law, d phi by dt term should be equal to 0 because there is no resistance in the loop. So flux should remain constant. So what he will do is he will write area into number of turns into B. And B is mu naught n by x naught into I is equal to area. I am assuming that doesn't change much. Number of turns, fine. This is mu naught n upon some x will come into I prime should come. So basically a n mu naught, a n mu naught, n n. So there should be this I prime that I should write as I x upon x naught. So, I mean, in the equation that I have written previously, I should not be the right thing. We should replace it by I prime. But the matter of fact is, if we are assuming that x is not very large in comparison to x naught, that is why this term is quite small. So I prime being used as I works in the problem. That is why when I have written my energy here, I have directly written I, which is not the right theoretical thing. Just because I knew that this is working, I have directly written. But ideally, even if I write this I prime there to make the flux constant and write the energy properly and differentiate, you should get your answer. Just explain this point because somebody can come up with this idea that energy you have conserved, but flux constancy you have not maintained. So you can go back because the examiner may not give you that condition where we are presuming while solving the problem that extension is very, very small in comparison to the original length. So वो assumption लिया मैंने even while solving. So I think you got that idea. That is the right. Rest you will get your result as you solve your problem. Let me take one more configuration here. Now, this is a problem which is based on a homopole motor. So the question is, there is a wheel of radius r and moment of inertia J, okay, consisting of a large number of thin conducting spokes, and this is free to rotate about an axle. A brush always makes electrical contact. Just go through this configuration carefully. With one spoke at a time at the bottom of the wheel. है ना? Clear है? ऐसे घूम रहा होगा तो he is making contact with one spoke at a time, right? Now there is a battery of voltage V which feeds current through an inductor L into the axle through the spoke to the brush. There is uniform magnetic field pointing to the at t is equal to 0, the switch is closed. So inductor is there, this voltage supply is there, and these rotating spokes are there. Right? Now the question is, find the torque on the wheel and the motional EMF along a spoke as a function of the current in the circuit and the angular velocity of the wheel. And obviously, he is more interested in B part, that can we derive that IT and omega t function? That is his interest. Can we write that current as function of time and that omega as function of time? Let's see how it comes up. So as we try to close the circuit, a current gets driven in the circuit. So if I is there, is opposing it with some L. I'm trying to write it at general T, L di by dt. Now, as this current is flowing through the circuit, all the lines are open. So this is only the closed line. So this is how the circuit will move. And इसमें current आएगा बाहर की तरफ, and that will be I. And as I will be driven along one spoke outwards, right, magnetic force will come into picture. So L cross B will act at the center, and that will generate a force which is IRB, right? and that torque is generating omega. So at a general instance, if this has got omega, there will be an induced EMF, and this rod is moving in anti-clockwise direction in cross. So the inner side will have a higher potential than outer side, and that induced emotional EMF rather is half B omega into radius ka square. Just look into the polarity of the battery. This is only between the brush and the center, because the field is cross and it is rotating anti-clock. But omega did not came initially. Initially that current came, na? So current is being driven by the battery down. So that torque came, and that torque provided it a omega. I'm talking about a t which is just after t is equal to 0. So then things fall in place, because I mean, if you look into A part, that was straight. B isko solve kar lete hain. What is A part? You have to write the torque on the wheel as a function. This was fine. I mean, this is IRB into R by 2. No hassle in this. Anti-clock. And motional EMF is fine. Plus minus half omega. So let's go to the main question now, B part. What are the equations you are writing in the problem? So I will get a minus V term. I have got a L di by dt term. And then I have got that plus half B omega R square term. And that will be equal to 0. That is my first equation. And secondly, I want to write torque is equal to I alpha. So seems like d omega by dt. So let me write I dot here, I dot, and omega dot. So into moment of inertia J, that should be equal to torque. And that torque at that instance is coming out as IB R square by 2. That seems like IB R square divided by 2. That is what we are getting. Now take the derivative of this second equation. So you will have I dot B R square by 2. This becomes J omega double dot. Right? And now substitute. So I'll write here only. I'll have minus V. I'll have L I dot. I dot term is 2J by 2J by B R square omega double dot. That is your I dot term. And then I have a B R square by 2 omega, and that is equal to 0. Now carefully observe it. So seems like omega double dot is coming out as, try to write omega double dot. So it is minus B R square by 2 double dot omega plus V, and this complete expression divided by 2J, B R square by 2J. B R square, it is calculated 2JL. ऐसा कुछ निकल के आ रहा है ना? So now it is a SHM equation, second order linear differential equation. तो इसका मतलब oscillating I and omega are in picture. I mean, कोई भी एक लिख लूं. If I can solve for omega, then I is fine here. There are some boundary conditions which I have to utilize. Try to write one of them at least. Omega लिखना. Anti-clockwise direction में, what you think will be your omega as function of time. So let us write it carefully. This becomes now minus B R square by 2 भी बाहर ले लो, is B square R4 by 4JL, and then I have omega minus, and I need a plus V. So V, B R square So divided by BR square and by 2JL, so 2. Is this fine? Okay. And I mean, you understand omega minus 2V by BR square को you just substitute this term as your omega prime kind of thing. तो फिर सब कुछ बढ़िया लग रहा है. Omega prime double dot seems like minus B square R4 upon 4JL into omega prime. Right? So now I think you are there with your solution. Right? So this implies what is your root for omega prime? So I should write omega prime is equal to, write it. A sub, let me use the constants like that only. A sine kt use kar leta hu, kt plus phi. Something here. And k seems to be br square upon 2 root jn. ठीक है? All good up to this stage. And finally, you should substitute your omega prime as omega minus 2v upon br square. Now, I think the only unknown in this equation which is required, omega t is your answer. There are two unknowns, a term and phi term, and you know two values. At t is equal to 0, now use boundary conditions. At t is equal to 0, you should make omega 0, and you should also use the current to be equal to 0 because inductor is there, so current cannot change suddenly. T is equal to 0 pe angular velocity and current both are equal to 0. So omega dot is also 0 at t is equal to 0 because omega dot depends upon current and omega itself is 0. So t is equal to 0 डाल दो, d omega by t. तो दो variables हैं, that phi and that a will be eliminated and that will give you omega as function of time. Omega एक बार आ गया तो you will get your current as function of time and everything will fall in place. Right? So I am not going through the calculations. You can spend 2-3 minutes more and try to go through the final calculations. I'll just dictate the final expression which comes up. Finally, omega as function of time comes out as 2v upon br square in bracket 1 minus cos omega t, and that kt term is br square upon that term, and your current comes out as v upon kl sin kt. Current भी आ जाता है. एक और चीज इसने बोला था that, and this is logical now. He said in the last part of the, after you solve everything, he said this part, that if there is a small resistance, then what will be the final state of the system? There are two ways to look into it. Ek to if you start solving this problem for damped oscillation and then the steadiness of damped oscillation, you will get your results. But by logic also, you can comment on the final result in an objective paper like JEE Advanced. If this is the system and the system has got a small resistance, then in the final state, what can we comment upon? Current and omega. And there is a concept of back EMF that we can use here. I'm making two comments and think about it. The thing is, this EMF which you are generating, that half b omega r square, in the final state, it seems to balance V. So as far as the final omega is concerned, it becomes 2V upon BR square, right? Steady state. And in that steady state, the final state, the current becomes 0. It should be 0. Otherwise, there will be an angular acceleration, which will keep on changing angular velocity, which will keep on changing the steadiness of the problem. So if there is damping in the circuit, if there is friction, little friction, that state will be achieved, right? Because you can go up to that state where back EMF will try to balance this V. So that little friction will help you achieving the steady state of a new damped oscillation. That is a theoretical answer to the question. So that's why he categorically said a small amount of friction and resistance. That will help us attain the steady state. Mathematically also it can be proved, but doesn't we don't need it at this stage of problem solving. Right. So fine, you go through these combinations once again, and I will pick up some more combinations tomorrow in your class. Take care and goodbye.